We have physics, velocity time graph, that is VT graph. What is velocity time graph? Velocity time graph is the graph that represents the motion of a particle along a straight line, or you can say that it is the graph of velocity against what time. That is what we call velocity time graph. Here now, this is y, and x axis, this is y axis, this is x. So here, because we say it is a velocity against time, we call here velocity, and you know that velocity, the unit is a meter per second. Here we call here time in seconds. So this is now, if a particle starts from rest, it means that this will start from here, move here. So here, where these two lines intersect, is called the origin in mathematics. But here we say that the particle starts from rest and accelerates uniformly, and they maintain a uniform velocity, then retard. That is called negative acceleration. So from here to here, if I call here A, B, C, let me say here D, and here E. So now if I call A, B, C, D, E, here is O already. So from here to here is called uniform acceleration. Uniform acceleration. From here to here is called uniform velocity. From here to here is called uniform retardation. Or you call it uniform deceleration. Now, I told you that this place is called velocity, this is time. When the particle starts from rest, it will start from here and move. If the particle did not start from rest, it may start from somewhere here. But here it is. Then there are things that you can obtain through this graph. This graph is what we call velocity time graph. There are things you can obtain from this graph. What are the things we can obtain from this graph? Number one is called acceleration. You may be asked to calculate the acceleration at OA. Another one is called retardation. So you can calculate retardation, that is negative acceleration. Another thing you can calculate here is called total distance traveled. Another thing you can calculate here is total time taking. Another thing you can calculate here is called maximum velocity. Another one is average velocity. These are the things you can calculate or you can obtain from velocity time graph. Then now this is when you talk about acceleration, you consider from here to here. So from here to here is the time taken for this particle to accelerate to this. Now here to here is called retardation. So the time taken for this body to come to rest is from here to here. Then next thing is called the total distance travel. The total distance travel depends on the nature of the graph. So if it is this graph now, the total distance travel will be area of this plus area of this. That is, if I call here x1, x2, x3, area of this plus area of this plus area of this. That will. The maximum velocity is this one. Then maximum velocity, that is the highest velocity the body attains before it comes to rest. Then the next one is called average. Average velocity is always calculated when you obtain the total distance. You divide it with the total time taken. That will give you average velocity. Now let's more on this total distance travel. I said that total distance depends on the nature of the graph. For example, total distance travel here, and the formula for calculating total distance traveled is not equals to area of this x1. You know this is a triangle. Area of x1 plus area of x2 plus area of x3. So this is a triangle. That is, it will not be equals to this total. This is half base times height plus length times breadth plus, this is called half base times what? Height. So this is the formula for calculating if this is the nature of the graph. But if it is not, you will not. If it is a trapezium with one side, you will still make use of area of this plus area of this to calculate the total distance traveled. So watch out for the example. Thank you.